This is one of the sites. That's how the channels look in there. And there's some equipment for salt dilution gauging, which was used for discharge measurements, just to know how much water is flowing through those rivers. There was a set of persistent organic pollutants analyzed, of 2 types. Polycyclic aromatic hydrocarbons, which are strongly associated, sorry for that, with coal and fossil fuels in general, as well as PCBs, which are usually connected to electrical equipment, for example, but it can be mining equipment as well. And those sets of analyzed components were summed up to produce a summary concentration. That's how the salt dilution gauging looks like. Some salt is dissolved, and then the lower the concentration of salt, the more water is flowing through a cross section. I'm just writing down conductivities in there. Other data was just field observations of when the snow and rainfall was happening, melt modeling of energy balance type, and as I said, river discharge gauging. So that's how the pollutant release curve looks like in 2012 summer season. We can see that there are different scales according to the type of pollutant used. There was a lot more polycyclic aromatic hydrocarbons in this site. And in general, during the field season, the concentrations were increasing. And some really high concentrations were connected to rainfall. Unfortunately, we had only 1 snowfall day during the field season, so I can't really say much on this subject. But there was the general increase. According to melt, this is comparison between daily melt from broken anode melt model, and in the background there's still the graph of concentrations. So sorry for this. So we can see that after melt events, there were some increases in pollutant concentration, but not in the beginning of the melt season. It's not in the snow period, more in the period when ice was already exposed on the glacier surface. So this comparison with those 2 additional sites, as we have a look through where these measurements should match. One of the sites, the second one, has more of a proportional change. The first one not so much, but in general, it's proportional concentrations. This site with less of match has more turbid water as well. That might be an additional factor that influences pollutant release. It's all said before, there was an increase during the melt season. There can be 2 factors influencing that. Perhaps there's more legacy pollutants already in the ice than in the fresh snow, but maybe there's also a particular dynamics to the release from snow. This dynamics can be depicted from a model like this one developed by Meyer and Weiger in 2011. And if we have a look how these 2 types of pollutants behave in snowpack melting, both PCBs and PAHs, of which fluorine is an example, will have a peak in the end of the melt season. So some of them are expected to be retained in snowpack till the very end of the melt. Another thing observed was that the rainfall was connected to some peaks in pH fluxes. If there is really retention from the snowpack, it would make sense for then intensive rainfall to cleanse the surface of small particulates to which the persistent organic pollutants can be attached. So just to wrap up, the factors that can influence the pollutant release dynamics from this short study that are worth looking at a bit more is rainfall dynamics and turbidity of the water. And that's probably because these two are connected to the particulate content in the proglacial waters. So here, thanks for listening, questions, and I'd just like to quickly thank for the funding received and for all the help in the field. And I hope to present some more on this subject later as I go through the data.
Okay, thank you very much, Christina. Has anyone got any questions? Okay, I'll have a question.
Yeah.
This study was just on one particular glacier. Do you think you would see changes in this sort of snowmelt period between like polythermal based glaciers and cold based glaciers, between warm based glaciers?
This particular glacier is mostly cold based, which I think is useful for preliminary studies because when we add to the complexity more turbid water from subglacial streams, it can be even more confusing in the beginning. But I think it's, yeah, the glacier dynamics is another complication to the picture. And it's not only whether was the thermal regime, but it's also how quickly is the glacier mass replenished. I'd send anyone interested to Hodgson's 2014 paper on black carbon, where he describes different types of glaciers for pollutant storage and release. And it means